White wire with a green stripe is commonly used to designate a neutral conductor in electrical wiring. While it's not a strict code requirement in all jurisdictions, it has become a widely adopted practice among electricians. This practice serves a crucial purpose. It helps in the quick and easy identification of the neutral conductor within an electrical system. This makes working with electrical circuits much safer and more efficient. In electrical wiring, the neutral conductor provides a return path for current back to the source. It's typically connected to the ground at the main electrical panel, creating a balanced system. The consistent use of white wire, often with the green stripe, helps to prevent accidental misidentification of the neutral conductor. This reduces the risk of electrical shocks or damage to equipment. While the National Electrical Code, or NEC, doesn't specifically mandate white wire with a green stripe for neutral conductors, it does require that the neutral conductor be identified. Section 200.6 of the NEC outlines the requirements for identification of grounded conductors. These conductors are commonly referred to as neutral conductors. The code permits the use of a continuous white or grey covering, or a white or grey marking at the terminations to identify the neutral conductor. The green stripe on a white wire serves as an additional visual cue, making it even easier to differentiate the neutral from other conductors. This is especially helpful in complex wiring scenarios where multiple conductors are present. Some local electrical codes may have more specific requirements regarding the identification of neutral conductors, including the use of white wire with a green stripe. It's always important to consult the local electrical code in your area to ensure compliance with all applicable regulations. The use of white wire with a green stripe is generally considered the best practice in electrical wiring, even where it's not explicitly required by code. It promotes safety, reduces the likelihood of errors, and facilitates troubleshooting. When working with electrical wiring, always exercise caution and follow all applicable safety procedures. Ensure that the power is turned off before working on any electrical circuits, and use appropriate personal protective equipment such as gloves and eye protection. If you're not comfortable working with electricity, it's always best to consult a qualified electrician. They have the knowledge and experience to safely and effectively perform electrical work. In summary, while white wire with a green stripe is not always a mandatory requirement for neutral conductors, it is a widely accepted and recommended practice in electrical wiring. It enhances safety and simplifies the identification of the neutral conductor, making it easier to work with electrical systems. Always consult local electrical codes and follow safety procedures when working with electricity. To further understand the role of the neutral conductor, let's consider its function in a typical 120 volts alternating current, or AC, circuit. In this type of circuit, the hot wire carries the electrical current from the power source to the load, such as a light fixture or appliance. The neutral wire provides a return path for the current, completing the circuit and allowing the electricity to flow back to the source. The neutral wire is typically connected to the ground at the main electrical panel, which helps to maintain a stable voltage and provides a path for fault current to flow in the event of a short circuit. This grounding is crucial for safety, as it helps to prevent electrical shocks and reduce the risk of fire. The white color of the neutral wire, often with a green stripe, serves as a visual reminder of its connection to ground. This helps to prevent accidental misidentification of the neutral conductor, which could have serious consequences. For example, if the neutral wire is mistakenly connected to a hot terminal, it could create a dangerous shock hazard. The green stripe on the white wire further enhances its visibility and helps to distinguish it from other conductors, such as the hot and ground wires. In addition to its role in 120 volts AC circuits, the neutral conductor also plays an important role in 240 volts AC circuits. In this type of circuit, two hot wires are used to provide the higher voltage, and the neutral wire serves as a common return path for both circuits. The neutral wire is connected to the center tap of the transformer, which provides a balanced voltage between the two hot wires. This allows for the use of both 120 volts and 240 volts appliances in the same electrical system. The consistent use of white wire with a green stripe for the neutral conductor helps to ensure that these circuits are wired correctly and safely. It also makes it easier to troubleshoot any problems that may arise in the future. When working with electrical wiring, it's important to understand the different types of conductors and their functions. The hot wire is typically black or red, and it carries the electrical current from the power source to the load. The neutral wire is white, often with a green stripe, and it provides a return path for the current. The ground wire is typically green or bare copper, and it provides a path for fault current to flow back to the source in the event of a short circuit. By understanding the differences between these conductors, you can ensure that your electrical wiring is safe and reliable. In addition to the color coding of electrical wires, it's also important to use the correct size wire for the intended application. The size of the wire is determined by its ampacity, which is the amount of current it can safely carry. The NEC provides tables that specify the ampacity of different sizes of wire based on the type of insulation and the ambient temperature. For example, Table 310.15. B16 in the NEC provides ampacity ratings for conductors rated 0 to 2000 volts. Using the correct size wire is crucial for safety, as undersized wires can overheat and cause a fire. It's also important to use the correct type of wire for the intended application. For example, some types of wire are designed for use in dry locations, while others are designed for use in wet locations. Using the wrong type of wire can lead to corrosion and electrical failure. When selecting electrical wire, it's important to consider the following factors. Firstly, the ampacity of the wire. Secondly, the type of insulation. Thirdly, the environment in which the wire will be used. Fourthly, the voltage rating of the wire. Fifthly, any applicable local electrical codes. By considering these factors, you can ensure that you select the right wire for the job and that your electrical wiring is safe and reliable. In conclusion, the use of white wire with a green stripe for neutral conductors is a common and recommended practice in electrical wiring. It enhances safety, simplifies the identification of the neutral conductor, and facilitates troubleshooting. Always consult local electrical codes and follow safety procedures when working with electricity. Remember to use the correct size and type of wire for the intended application and to understand the different types of conductors and their functions. By following these guidelines, you can ensure that your electrical wiring is safe, reliable, and compliant with all applicable regulations. The electrical work should only be performed by qualified individuals who have the necessary training and experience. If you're not comfortable working with electricity, it's always best to consult a licensed electrician. They have the knowledge and skills to safely and effectively perform electrical work. In addition to the topics discussed above, it's also important to be aware of the potential hazards associated with electricity. Electricity can be dangerous, and it's important to take precautions to avoid electrical shocks and fires. Always turn off the power before working on any electrical circuits, and use appropriate personal protective equipment, such as gloves and eye protection. Never work on electrical circuits while standing in water or on a wet surface. Be careful when using electrical appliances near water, and never overload electrical outlets or circuits. If you experience any electrical problems, such as flickering lights or sparking outlets, contact a qualified electrician immediately. By following these safety guidelines, you can help to prevent electrical accidents and ensure the safety of yourself and others. Electrical safety is everyone's responsibility, and it's important to be aware of the potential hazards and to take precautions to avoid them. Remember to always consult with a qualified electrician if you have any questions or concerns about electrical safety. They can provide you with valuable advice and guidance, and they can help you to ensure that your electrical system is safe and reliable. The information provided here is intended for general educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. I hope this information has been helpful and informative. Thank you for your time. Remember, safety first when working with electricity. Always follow all applicable codes and regulations, and never take risks. Electrical work can be dangerous, but by following the proper precautions, you can help to prevent accidents and ensure the safety of yourself and others. If you are unsure about any aspect of electrical work, it is always best to consult with a qualified electrician. They can provide you with the expert advice and guidance you need to complete the job safely and effectively. Furthermore, continuous education and staying updated with the latest electrical codes and best practices are essential for anyone working with electrical systems. The electrical industry is constantly evolving, with new technologies and regulations being introduced regularly. By staying informed, you can ensure that you are providing the safest and most reliable electrical services possible. The use of appropriate tools and equipment is also crucial for electrical safety. Always use tools that are designed for electrical work and ensure that they are in good working condition. Inspect your tools regularly for any signs of damage and replace them if necessary. The proper use of testing equipment, such as multimeters and circuit testers, is also essential for troubleshooting electrical problems and ensuring that circuits are properly de-energized before working on them. Finally, remember that electrical safety is a shared responsibility. Encourage others to follow safe practices and report any potential hazards to the appropriate authorities. By working together, we can create a safer environment for everyone.